explain you the third part of the experiment, that is short circuit test. And the circuit is given here that we are going to use. So this short circuit test has been designed to calculate the winding resistance of the primary and the secondary of the transformer. As you know, this is the primary part and this is the secondary winding. So for this part, we have to short circuit the secondary winding. For short circuiting, we will use this cable because there will be like 100 amps going through it, so we need a bigger cable. And before I use that, I should tell you that this is a current transducer. So if I make a turn here like this, so this will be my primary side of the transformer, and then this will be the secondary side. So this will step down the current, and it's rated 120 to 5 amps. So if I have 120 amps here, I can get 5 amps here. So the secondary connection has been done. From here you can read amps. So I will make a connection to the ammeter, and I will use the 5 amps meter because the rating of this one is 5 amps on the secondary. So the secondary part is done. Now we have to move on the primary part. For the primary part, we always start from R phase. Then we move to the voltmeter. So if you look at the circuit and coming out of the voltmeter, you have a ammeter that's rated 25 amps. So I will connect it to 25 amps, and this is my 25 amp meter. And then in the circuit, if I come out of 25 amps, I have to go to the ammeter. So when I come out of the 25 amps, I have to go to the CT. So now, as we know that the turn ratio of the CT is 120 to 5, and from the rating of the transformer, the rated current of transformer will be like around 20 amps. So it's a very low current. So we need to fix some turns here around the CT so we can increase the sensitivity. So I will make 4 turns. So if you pass this like this, it's 1 turn, and then you can pass it like this. So there are 2. So now there are 3. And now I have 4 turns on the CT. So I connect one part here, and the second part I should connect it to the transformer. So now if you look at the picture, you are done with the CT. You go inside the CT, you connect the winding to the CT. Now for the secondary winding, you have to make a loop through 2 ammeters. One is of the wattmeter and the other one is a 5 ammeter. So if you come out of here, you go to the 5 ammeter, and when you come back, you go into the ammeter of the wattmeter, and then you connect it back to the CT. So this completes the loop. So this is a loop. And now we need the voltage for the wattmeter. So what you have to do is just connect this voltmeter in parallel to this voltmeter. And you connect one winding of the transformer to the neutral, that is black. So this will be my neutral coming directly. That's all? Yes. So this is my phase supply that I'm going to use. I will use single phase supply, so I will switch it on to 1. Before you turn it on, you make sure this is 0. This cannot turn around to the left, so you make it sure. Now just put it to 1. And so you remember in the open circuit test, we applied 220 volts. Now this is a short circuit test. So we have to apply the rated current. In the open circuit, we applied the rated voltage. And my rated current is like around 20 amps. So I will look at this meter, and I will increase the current little by little when I reach 20 amps. So you can see you have all the readings from the meters, and you are applying 20 amps to the primary of the transformer. Now can you read this? No, because the needle went downside. So what you need to do is like you swap one of the terminals to make the power flow reverse. So before doing that, I will switch off the power supply, and I will bring this current to 0. I will switch it off, and then you have to swap the terminals, so you change the power supply. So now your needle is moving upwards and you can read the power. So our experiment is done here.